welcome to another Gungahlin College Maths Applications online lecture. The topic of this lecture is going to be basically just another application of matrices. So this time we're going to look at using matrices to summarize information. So the example that I'm going to do for this is a pretty silly little example, but it's one that's a lot like ones that you might see in your textbook or on an assignment or on an exam. So what I'm going to look at is basically trying to organize some information to do with market share of fast food restaurants around Gungahlin College. So I'm going to say, and again, so these are completely made up numbers, but I'm going to say that maybe McDonald's, and I'll write that as M, has a market share of 50% for Gungahlin College students at lunchtime. And maybe Hungry Jack's has a market share of 20%. And Porto has a market share of 30%. And like I say, completely made up numbers. So that's in a table form, but I could also write this as a matrix, right? I could say that the market share, so I might call the matrix M. So this M now is for market share, not for McDonald's. So I might write it as the matrix 50%, and I'd write it as a decimal instead of as percentages. So 0.5 is the same as 50%, 0.2 is the same as 20%, and 0.3 is the same as 30%. So again, this would be McDonald's, this would be Hungry Jack's, and this would be a Porto. And that's the matrix representing the market share of those fast food restaurants. Now I could also, let's say, from one week to the next, the market share of these three restaurants changes, okay? And let's write these changes in a table format, and then we'll change it to a matrix, okay? So I'm going to say that, I'll write again McDonald's here, Hungry Jack's here, and a Porto here. And over here, I'm going to write, so again, McDonald's, Hungry Jack's, and a Porto. And this is going to be the percentage retained, so kept by a restaurant, or gained from another restaurant, or gained. So I'm going to say that McDonald's, from one week to the next, retained 90% of its customers. And I'm going to say, actually, maybe the Hungry Jack's shut down for the week for whatever reason. So McDonald's gained a bunch of customers from Hungry Jack's, say 60% of their customers, and they gained 5% of a Porto's customers. The Hungry Jack's, if they shut down, right, they would have gained 0% of McDonald's customers. They would have retained 0% of their own customers, and they would have gained 0% of Oporto's customers. Oporto, on the other hand, so if McDonald's retained 90% of its own customers, that must mean that 10% went to Oporto, so 10% of McDonald's customers were gained by Oporto. The other 40% of Hungry Jack's customers went to Oporto, and they retained 95% of their own customers. Okay, so again, table format. I can also write this as a matrix. So I'm going to label this matrix T. This T is going to stand for transformation. Transformation. Okay, so this transformation matrix, again, all I'm going to do is basically copy this data over into matrix form. So 90% is 0.9, 60% is 0.6, 5% is 0.05, 0% is 0, 0% is 0, 0% is 0, 10% is 0.1, 40% is 0.4, and 95% is 0.95. Okay? Now, what I'm going to suggest to you is that using matrices and using matrix multiplication, we can actually calculate the new market share. And in particular, the new market share, which I'm going to denote by n, is equal to this matrix T, which stands for the change in market share, times the old market share, M. So the new market share is equal to the change in the market share times the old market share. So what I'm going to do is now just do this matrix multiplication and then try to convince you that the numbers we get actually correspond to the new market share. So let's do this matrix multiplication. So T is 0.9, 0.6, 0.05, 0, 0, 0, 0.1, 0.4, and 0.95. Okay, and M, the original market share, was 50% for McDonald's, 20% for Hungry Jack's, and 30% for Oporto. So let's do this matrix multiplication. Okay, so this is a 3 by 3 matrix, and this here is a 3 by 1 matrix. So I can do this matrix multiplication, right, because these two numbers match, and furthermore, the size of the matrix should be 3 by 1. Right, so 3 rows in 1 column. Okay, so let's do this matrix multiplication now. So the first row, row 1 times column 1, 0.9 times 0.5 plus 0.6 times 0.2 plus 0.5 times 0.3, sorry, 0.05 times 0.3. Second row, 0 times 0.5 plus 0 times 0.2 plus 0 times 0.3. 0 times anything is 0, so this whole thing will be 0. And for the third row, 0.1 times 0.5 plus 0.4 times 0.2 plus 0.95 times 0.3. Okay, so now we can simplify, and you might like to get out your calculator and do this, but I'm just going to do it in my head. So 0.9 times 0.5 is 0.45. 0.6 times 0.2 is 0.12. 0.05 times 0.3 is 0.015. 0 is 0. 0.1 times 0.5 is 0.05. 0.4 times 0.2 is 0.08. 0.95 times 0.3 is 0.285. So now I can simplify this further by adding these up. And what do I get? 0.45 plus 0.12 is 0.57, plus 0.015 is 0.585. 0 is 0. 0.05 plus 0.08 is 0.13. 0.13 plus 0.285 is 0.415. Okay, so what this is actually saying, right, is that McDonald's new market share is 58.5%, and Oporto's is 41.5%. And we can see that this is actually what it is. Okay, so first of all, we should check this and think about it. Okay, so it makes sense that if we started off with 100% market share spread across all three, we should wind up with 100% spread across all three. So these two numbers should add up to 100%. 58.5 plus 41.5 is indeed 100%. That's one thing. Another thing is, let's go back and just sort of think about what we actually did when we did this matrix multiplication. So let's look at these numbers here. So in order to work out the new market share, we took 90% of McDonald's original market share and added to that 60% of Hungry Jack's 20% and 5% of Oporto's 30%. So they gained this, and they retained this. So those are where all the different components of McDonald's new market share comes from. And the same thing goes for Hungry Jack's and for Oporto. So hopefully that's enough to give you some sort of feeling for some of the applications of matrices. So I know that some of these applications seem maybe a little bit silly, and that's just because they're the simplest ones that we can give you. So there are some more interesting applications of matrices. Some of these are things like cryptography, so code breaking, and also they come into play lots in IT, physics, and engineering. But for now, these are the ones that you really have to worry about. So until next time, see you guys.